Here is an entire time series question that we're going to do. Now, we're going to start with some sales figures. I've created some sales figures here, and we're going to do an entire time series analysis and then make a prediction for, let's say, spring 2022. So we're going to have a look at everything to do with time series in a single example, and I'd like you to follow through with me. Now, the first thing we need to do is we need to put our information into the calculator. So step one is the calculator. And what we're going to need to do is construct our X and our Y. Remember, X series, or my explanatory variable, is time, and my Y series, or my responsive variable, will be sales. What we're going to do therefore is we need to work out how to manage our time, because our sales are obvious. We can see the sales figures here, but the time we're not so sure. So what we're going to look at is, first of all, the very first season we have in this entire set of data is summer 2017. So I'm going to call that a time of 1. Then the second season is autumn. The third season is winter. And the fourth season is spring. Now the season after that is summer of 2018. It immediately follows spring, and therefore we're going to call summer of 2018 season 5. Not season 1 again. Summers won't always be season 1s. We follow through, so the next season, or the next week, or the next day has the next number for time. And so therefore it'll follow that autumn is season 6, winter is season 7, spring is season 8, summer of 2019 is season 9, autumn 19 is season 10, winter of 2019 is season 11, and spring of 2019 is season 12. So these points here now form our X and our Y columns on our calculator, where my X's are numbered from 1 to 12 according to these green numbers, and my sales, or my Y, I'm probably going to call them S for sales, will be the black numbers listed for the sales. Now, putting that into the calculator, my data will look something like this, and you can see as I read down the S column, 12, 62, 176, 47. Then the next number, season 5, is 14, 68, 193, and so on. The next thing I'm going to do is graph this. And to graph a time series, I'm going to go for an XY line where my X list was my time and my Y list is S for sales. And then I set that and hit my graph button, and you can see my graph looks like this. So let's have a look at what we can see. We have definite repeating behavior here, and it's quite predictable. So let's talk about this predictable variation, and it's called seasonality. Now, seasonality, first of all, as I said, is predictable. So we'll make a note of that. It means that we can work out, when we have a look at our plot, that every time we have the 1, 2, 3rd season and the 7th season and the 11th season, all of these seasons, and you can see here in the winter category, these are significantly higher than all the other seasons. What we need to do is we need to take into account that by the looks of this data, winter will always be a lot higher and summer will always be a lot lower than the average value. And what we're going to need to do is to deseasonalize the data, which means we take this shape out of the data to turn it into a more straight line. So if you have a look at our summary board here, you can see that seasonality is predictable, and we're going to focus on the fact that these points are always high. And we're going to deseasonalize to take this shape out of the line, and hopefully we're going to end up with a line that looks more like that. So when you deseasonalize, you have to work out the seasonal index. Now the seasonal index tells me how much higher than this purple line each of those points are. So I need to calculate the seasonal index. And the seasonal index, first of all, a seasonal index of 1.0 says that it's the average value. Would put it right on the line. So if the seasonal index is larger than 1, then it means the point is above the line. If it's smaller than 1, it means the point is below the line. The value of the seasonal index tells me in percentage terms where that point is in relation to the line. So if something under the line might have a seasonal index, for example, of 0.8, which is 80% of the value of the line, or 20% less than the average value. And that's what we're looking for. This 20%, because 80 plus 20 is the 100. So 20% less than the average value would be what a seasonal index of 0.8 is. And the seasonal index is the value for the season in question over the average value for all of the seasons. And that's what we'll be looking for and calculating now. So let's start by looking at 2017. And whenever we have more than one year, we look at the seasons separately. So we're going to look at 2017. And we need to work out the average seasonal value, the average value for a season, which means adding all of these four numbers up and dividing by 4. So my average value equals 12 plus 62 plus 176 plus 47, all of that over 4. So I'll pop that into the calculator. Of course I'll use my fractions button, because if I don't do that I can make mistakes that I don't want to make. So there are my numbers all over 4, and I end up with 74.25. And that means to calculate my seasonal indices, I will put each of these numbers over 72.45. So therefore, summer 21/7 has a seasonal index of 12 over 74.25, which equals, again, we'll go to the calculator, 12 over 72.45 gives us 0.166, and I'll do everything to 3 decimal places. I'll do the same calculation for each of the other seasons, and then I'll come back to you. And there are my calculations. So now I've worked out the seasonal index for each of the seasons in 2017. I'll then need to work out the seasonal index for each of the seasons in 2018. So again, I'll need to work out the average, which is 14 plus 68 plus 193 plus 51, all over 4. And I can see here that the average is 81.5 for that year. So that means I need to divide each of these numbers by 81.5 for 2018. So summer 2018, the seasonal index will be 81.5, will be 14 divided by 81.5, because I'm dividing the number by the seasonal index, and then I get 0.172, and that will be my summer seasonal index. And I'll go through again and divide autumn 68 by 81.5, winter and spring for 2018. Then I'll repeat the process for 2019 until I have a table that's complete, like this one is for the line of 2017. Now the bad news is we're not done yet. There's our table of seasonal indices for each of these seasons based on each year. Now we need to work out summer's overall seasonal index, and the overall is the average of these three numbers. So when I put them into the calculator, the average of 0.162 plus 0.172 plus 0.189, all divided by 3 because there are three numbers, is 0.174. So that's the average seasonal index for summer. Now I'm going to do the same process for autumn, winter and spring and end up with the overall seasonal indices for these months across the 3 years. And now I've calculated my overall seasonal indices for each of the 4 seasons. And I can check by seeing if they add up to 4, because the average is 1 and there are 4 seasons. So because there are 4 seasons, the sum will equal 4. And if you put those numbers into your calculator, you'll be able to check that they actually add up to 4. So then I know I'm in pretty good shape. But wait, we're still not done yet. Now we need to calculate the deseasonalized actual figures. So I need to divide, deseasonalizing means I'm dividing. Now I'm going to divide by my seasonal index to take out the shape. This is the whole point of this exercise. So as I said, to deseasonalize, we want to divide. We're just going to write that down because the D's go together. To deseasonalize, we'll divide by the seasonal index, which means the deseasonalized, the unshaped value for summer 2017 will equal 12 divided by 0.174. And I'll put that into the calculator. Lots of calculations you're going to have to do for this. And you get 68.97. So I'll write that down. For autumn, the deseasonalized value will be 62 divided by the seasonal index for autumn, 0.834, and that is 62 divided by 0.834, 74.34. For winter 2017, it's going to be 176 divided by the seasonal index, which is 2.350, and that will be 74.89, and so on. Spring is going to be 47 divided by 0.642. And what you'll notice is these numbers start to be quite a bit closer together than they were when we started. That's what would indicate that you're taking the shape out, because they'll all be gathered much more around the straight line. I'm going to complete the table of deseasonalised numbers by the same process now. And finally, here we have all our deseasonalised values for our sales figures, and you can see they're much more similar. Now, these are the figures that we're going to start operating with. You'll notice right now I haven't gotten rid of my seasonal indices because I'm going to use these later on. And remember, we're doing this to make a prediction for the future. Now here's the data that I've found, the deseasonalised data, presented a different way, and you can see I've got summer, autumn, winter, spring, summer, autumn, winter, spring. So it's exactly the same way that we numbered our seasons. And now that we've taken out the predictable shape, we need to look at the random shape. And taking out the random shape is a process that we call smoothing. Now smoothing it's easier to do smoothing with medians than with means, and medians have an advantage in that means are more susceptible to outliers or unusual points. So smoothing is all about taking out unpredictable random variations, whereas seasonality is all about taking out the predictable variations that often come with, as you guessed it, season. Here I'm going to do my smoothing in orange, and I'm going to use 3 median smoothing, which means what I'm going to do is find the median of these first 3 numbers. Now, if I were numbering the seasons, as I did in the start, these seasons would be numbered 1, 2, 3, 4, 5, 6, 7, 8, and so on. What you'll notice is when you do 3 median smoothing, I'm going to find the median of these 3 numbers for this value. And that means season number 1 will have no smoothed value for 3 median smoothing. Then I'll look at these 3 numbers, and for season number 2, I need to put these in order. Fortunately, by luck, they already are. The lowest number is 68.9, the highest is 74.9, the middle is 74.3, so the smoothed value is going to be 74.3. Then I'm going to look at my new value for season number 3, and if I look at these numbers and I put them in order, the lowest is 73.2, the highest is 74.9, and the median is 74.3. I'm going to keep doing the process. So for season number 4, I look 1 before and 1 after, and if I go lowest, medium, highest, I can see the median number here is 74.9. And I'm going to keep going through for every single season. And what I'll find as well is that my season number 12, I won't have a smoothed value because I would need to look at this value and I don't know what it is. So I'll do that and then I'll come back to you. And here they are. And wouldn't you know it, finally, these are the numbers that we're going to put into our calculator. These now 10 numbers. You'll notice there's no value for season 1 and there's no value for season 12. So I'm going to put these smoothed values into my calculator. And here they are. So now with these values, you'll notice there is no point for number 1 and no point for number 12. It is not okay to leave number 1 in there and call it a 0. That will stuff up your data. So that's not okay. So I've only got points from 2 to 11 and I've used my smooth values. Now I'm going to find my regression line of the smoothed deseasonalised values. So I will go to Calc, Regression, Linear Regression. Remember, T is time, that's my X list, or my explanatory variable. S is sales, that's my Y list or responsive variable, and I get the equation Y equals A plus BX of A is 68.9 and B is 2.01. So that means my equation will be Y equals 68.90 plus 2.01x. Or if I wanted to use the original variables, sales equals 68.90 plus 2.01 times time. And now I've written that in the context of the question, and this is what I'm going to use to make my prediction. So here's my equation, and again I want to reiterate, this regression line is the line for smoothed and deseasonalized data. First we took out the predictable shape, then we took out the random shape, and now we've got this equation. Now if you remember way back at the start of this, we were looking for spring 2022. Now spring 2022 is where time equals 24. And if you're ever not sure, then just count on your fingers. Which means my sales, my deseasonalized sales, will be 68.90 plus 2.01 times 24. And I'm going to put that into my calculator. It's worth keeping in mind that I've just accidentally sketched that, and you can see that now this data is much more smooth. It looks like there could be a bit of a cycle, but actually that's random because when I count the points, it's not every 4 months or 4 seasons. It's all over the place, even although it does look quite patterned. Now, this line here is my regression line. This line here is the 68.9 plus 2.01. It's a much more smooth curve. Now what I can do is go to my main, put in that equation, 2.01 times 24, and I get 117.14. So that is my deseasonalized figure for spring of 2022. You'll notice that that was all about the figure that had the shape taken out of it. The predictable shape has been taken out of this. It's deseasonalized. So now we need to put the shape back in. We're nearly done. What we've done is, this was the original graph. We've moved all the way up the purple line beyond this graph to 3 years in the future. Now I know the blue shape is very predictable, but my 117.04, that is all about the purple line. What I need to do with this is put in the blue shape, and to put in the blue shape, that's called seasonalising. So S for seasonalising and S for shaping it again. So just to try and show you what I'm doing, I've copied this graph over here back to here. Now, we are looking at spring of 2022, which means this blue graph is going to keep going down and up and down and up and down and up like that. And at some point in time, here is season number 24, which is spring 2022. My prediction of 117.04 is right on this purple line. It's my purple line prediction. So I need to re-seasonalize, and I seasonalize by multiplying by the seasonal index. So the last thing I do is I put the shape back in by seasonalizing. Now, I know that spring has a seasonal index of 0.642. And if deseasonalising de-shapes by dividing, then seasonalising will shape by multiplying. So I'm going to multiply my value of 117.04 by my seasonal index to get the actual predicted value. So 117.04 times 0.642. And I'm going to put that into the calculator. And I already have the 117.14 there, so I'm going to multiply by 0.642, which is the seasonal index for spring, and I get 75.2 sales, which when rounded down will be 75 sales. And that's actually where we predict our blue line will be way off into the future. Now this entire video has gone through everything to do with time series, and it's understandable if there are some things you need to watch 2 or 3 or more times before you get it. Congratulations also on getting to the end of the longest video I've ever made. I hope it made sense. Good luck.